We're going to use linearization with Google Sheets to find a graph's math model. By the end of this video, you should be able to characterize a graph as a linear function or a power function, make a test graph by replacing the independent variable with its power, and for a linear test graph, evaluate the slope and y-intercept, and lastly, to write the equation of the line in terms of the new variables. We're going to take a look at this graph that we created recently of pressure versus volume. And it looks like it's a pretty curvy trend here with the data. So we're going to try and find the mathematical model that connects pressure and volume through this process called linearization. And we're doing it in Google Sheets in part because it's nice to know an online graphing program that's free and that you don't have to download. You don't have to have where downloaded on your computer, etc. And this is something that will carry you through your entire academic career in high school and beyond in college. This is becoming very, very common to use in many science courses, math courses, etc. So we're going to make a guess at what type of relationship this is. It is some kind of power function. The resource is called Unit 2, Reading 4A, Curve Fitting by Linearization. You could read the few paragraphs on top, but let's get down to the nitty-gritty and look at some general graph shapes and what kind of relationships they are. Most simplest is no relationship. And there's two kinds of linear relations. There's direct, that goes right to the origin. These are directly proportional linear relationships. And then there's just plain old linear relationships that don't go to the origin. The next graph in this reading is hyperbola. Inversely report. To linearize it, we'll make a test graph of y versus 1 over x instead of y versus x. And if we do get that proportionality, we can evaluate the slope and the y-intercept. So let's give it a try. Okay, it's just a direct copy, so in case I mess up, I could try again and I won't have completely lost my data. So we decided that this is looking pretty much like a hyperbola, that pressure is perhaps proportional to 1 over volume. So I'm going to insert a new graph after I manipulate the volume column in this set of data. So I'll show you how I'm going to do that. It's pretty powerful. Now I'm going to show you how to do this pretty easily using Google Sheets math functions. We want to replace this column with 1 over the volume instead of the volume. So I'm going to first, before I do that, change the title to 1 divided by the volume, just so I'll remember. And I'm going to just shorten it up. And so our units will now be 1 over milliliters. So it's inversely. Okay, now I'm going to click on this cell and I'm going to replace it with a math function. I'm going to say equals. And then I'm going to do 1 divided by, and I'm going to select from column A this first cell with a number in it. All right. And I could press my return key, and that is 1 over 1.50. All right. Now I'm going to go back to that cell. I'm going to grab this little blue dot and carry it all the way down. All the way down. You could do it in one smooth swoop if you'd like. All right, so it's got very, very not rounded data. We could find a way to reduce the number of significant digits here, but I'm not going to worry about that right now. So let's see what the graph of pressure versus 1 over volume will look like. Okay, before I insert a new chart, I'm going to highlight the data I want graphed. So this will be the independent axis, and this will be the dependent. And I go to Insert Chart. And I'm going to select a scatter chart, scrolling down, finding scatter. And I'm going to insert. And you could already see that it's looking pretty linear. Somehow messed up the title of the graph, but we could go fix that. So it seems to have messed up the axes labels, but we could fix that. So we go to the editor, Advanced Edit, and let's give it a proper title. And now we're going to label our axes. We're going to enter the title of the horizontal, the x-axis, and we're going to call it 1 over the volume, and the units are 1 over milliliters. And enter. And now we're going to name the vertical axes as pressure. That didn't change. And the units, atmospheres. Oh, before we update, it's looking pretty linear, so automatically we should evaluate the line. So we'll do a trend line, linear, and then scroll down, and we will put the label of the equation on the graph. And for today, we'll show the r-squared value. You'll learn a little more about that when you take statistics or some higher level math science classes. And let's go update. Okay, so here we have pressure versus 1 over volume being a very linear fit, going pretty much to the origin right here. Okay, so now we're going to write down the equation of the line in terms of our slope and our intercept. Let's first start with just our regular mathy type variable names y and x. So we're going to write down the equation of the line, and so y equals, and I'm going to replace the value of slope of 1,558. And I'm not going to worry about the units right now. I'm just going to write down what it shows me under, and I'm going to multiply it by x, and I'm going to add the y-intercept point. Okay, so that's a good first step to writing the math model. The full math model would include the variable names of pressure and volume, as well as their units. So I'm going to do that next line. I'm going to write pressure, which is y, equals 1,558. And now I'm going to write the units. We have atmospheres divided by, and then the run units are 1 over milliliters. And instead of writing x, I'm going to write down in parentheses. No, I'll just separate it with a times 1 over volume. And now I'm going to think about, do I need to consider to add this y-intercept value? We could see that it's extremely small in comparison to the maximum pressure. It is well under the 5% limit of considering whether that's a believable intercept. So we're just going to leave it off. And that is then the equation of the line.